DMX Music's video training series presented by North American Field Operations. In this module, we will look at the proper tools, equipment, and procedures to perform a professional DBS installation.
In this section we're going to discuss DBS technology, and I think it's very fitting that we go ahead and talk about a very brief history of how satellites have come about. In 1957, the Russians or Soviets launched a satellite about the size of a basketball up into space, and that was called Sputnik. You probably heard about it before. And in 1958 the United States retaliated. I believe the name of it was Project SCORE, and they were both launched into what we call polar orbits. These orbits are elliptical, and the reason that they are called polar is because they go around the poles, North and South Pole. And testing went on and continued, and the space race began. And great advances were made at that time. The first satellites only stayed in orbit, roughly 10, 12, 13 days. Now, of course, they stay in orbit for much longer. But in 1963, the largest leap in satellite technology was made when the United States launched a satellite into what we call the geosynchronous orbit, or around the equator. Now, the benefit of a geosynchronous orbit versus a polar orbit is, if you're in a spot in the United States, this satellite stays stationary, and it basically moves the same speed as the Earth rotates, thus staying in a fixed position. Whereas a satellite that rotates around the polar orbits, when you have a fixed satellite antenna, can only be viewed very briefly. Today we use satellites for all types of things: weather forecasting, ozone prediction, telephone communications, TV, and of course music. So satellites are launched via rockets out of the Earth's atmosphere, and some interesting figures here is that if you launch a satellite out into outer space faster than 23,500 miles an hour, it actually breaks the Earth's orbit and continues to travel off into space, and via inertia just continues to travel forever and ever and ever. However, if you launch one around 17,000 miles an hour, it will take place into the Earth's orbit and continue to rotate around. Any slower than that, and you get to see it again because it's going to come back and visit. So satellites being launched into space is a very delicate balance of speed and gravity. Now, how the satellite stays in the position is something called centrifugal force, and that's a combination of this speed that the satellite is traveling and the gravitational pull of the Earth. Very similar to if you were a kid, you ever took something on a string and spun it around and it maintained a perfect circle. That's called centrifugal force. Okay, now we're going to discuss how the signals are sent to the satellite and back down to the Earth. This is called uplink and downlink. Now, we have a facility at DMX located in Denver that takes our digital music content, bounces it off the satellite, which then in turn bounces back down after a little bit of manipulation to the fixed antenna that we install at the customer's location. That signal then travels via the coax to the receiver and is turned into music. Now, this is a pretty amazing task if you think about it. It's very similar to shooting a bullet off of a target 22,300 miles away, and then that bullet ricocheting, returning back to the Earth, and hitting another target about the size of a quarter, which is a pretty amazing feat, and it's all done at incredible speeds. However, with the tools that we use to perform our installations and the methods that we've devised, it can be done very easily, and you'll see that later on in this video when we get up on the roof and actually adjust the dish. Next, we want to talk about the downlink portion in more detail. When the signal comes back down to Earth, it covers a certain portion of the Earth, which is called the footprint. Now, the footprint, to give you an analogy, would be like shining a flashlight on a basketball. The closer you get to the basketball, the less area you would cover, and the farther away you get, the bigger area that you would cover on that basketball. Because the satellite is located 22,300 miles away, the size of that footprint, or the amount of light that covers the basketball, is roughly 42% of the Earth. So in theory, we can cover the entire Earth with 3 satellites. And that signal is very steady, very constant, because it is in a geosynchronous orbit, and is pretty much uninterruptible with 3 exceptions that we're going to discuss today. One of those is what we call solar conjunction, or sun outages, sunspots. And that happens when the sun, the satellite, and your fixed dish are in perfect alignment. The sun's radiation actually takes over the signal and knocks it out. Now, this happens from 20 days prior to the equinox to 20 days after the equinox, and the equinoxes are twice a year. And this alignment only happens roughly for 1 minute to 2 minutes at each location, once a day for these 40 days. The second type of outage that we can have is called rain fade or snow fade, and this occurs when the satellite signal tries to travel through moisture in the form of rain or snow, and the moisture actually blocks the signal from getting to the satellite dish. A way you can simulate this when you're up on the roof and installing and aligning, once you have your dish aligned, is to take your hand and place it in front of the LNB, slowly covering more and more, getting closer and farther away, and watch the meter. The signal strength will go to a higher number, which means you're getting less signal, and as you move your hand away or further away, it'll go back to it, closer to its original number. And then the third type of failure that we can have is an uplink failure. Now, this can happen if we have a bad piece of equipment in our uplink center, just equipment failure, or if they happen to lose power through a power outage from the power company. We do have backup generators, but sometimes those can blow too. So that pretty much covers everything that we want to talk about here today in satellite technology. We thought we'd give you a broad understanding of how this stuff works. And the important thing to remember here is that our portion is installing this antenna and knowing how the signal reaches that antenna. And that's all. Next, we're going to be covering the tools that are necessary to start and complete a DBS installation. Here's the tools required to complete a DMX DBS installation. First, screwdrivers. You're going to need both a slotted and a number 2 Phillips screwdriver. In addition, it's also a good idea to have a right-angled screwdriver, which is shown at the top of the picture. These are utilized to snug the LNB bolts when assembling the LNB. Next is a socket set. You're going to need both the 10mm and 13mm in shallow and deep socket versions. Next, we have cutters and adjustable wrench utilized to cut the RG6 coax or RG11 as the case may be, and to tighten bolts on the satellite dish. Rope and block grabbers. These are an optional item. Makes it easy to pull blocks up onto the roof These are shown later on in the video. Compass, utilized for site surveys. You definitely want to make sure that you have a good look angle before you do a lot of hard work and install a dish somewhere that doesn't have a clear view of the southern sky. That's just a tip because I've done that before. Remote power source, extension cord, and a DC AC inverter. These are utilized to get some type of power to your receiver so you can align your satellite dish. RG6 crimper and stripper. These are utilized to make connectivity to the satellite dish and to your head end. We typically utilize these for single piece F terminations. There's different dies available for different types of cable. Sealant and tape. You see that we have the sealant in a bag. This will be used later on in the video to seal our entry into the building via the pitch pocket. Also, the tape is a self-vulcanizing tape. Good to use when you're using a single piece F connector. Not necessary if you're using a snap and seal type. Okay, here we have all the pieces that have come out of the boxes, and we're going to show you how to assemble the dish. First step is the mast. Start by folding the mast arms down and installing the wind brace. It's a good idea here when you're installing the bolts on the sled to make sure that the heads are on the inside, so when you place your ballast or cat blocks in the sled portion, that the bolt heads don't interfere with that. Next, you need to move the mast once the arms have been tightened. You can see here it comes with a 1/2 inch gap. After you loosen the bolts and slide the mast forward, you'll see the gap is gone. Next is the bolt. Tighten that up. And our sled is almost complete. Okay, the reflector portion. You want to note here that you have side holes and bottom holes that the feed arms mount to. First thing that we want to do is install the mast mount. And very important to note the orientation of the mast mount to the bottom hole. That bottom hole is for the bottom feed arm assembly, and the mast and that need to line up together. If not, your dish is going to be sideways or upside down when you try to put it on the sled. Just about got that wrapped up. And the next step is installing the feed arms. There's two types of feed arms. There's the longer ones with the angled bottom. Those go on the side holes. And the short straight pole goes at the bottom hole. You want to hand tighten these bolts so they're movable but snug. When we go to install the L&B mounting bracket, we want to be able to move those just a touch. And we'll snug them up after we assemble that portion. Note here that on the bottom hole has a screw that taps into the arm itself versus a nut and washer type assembly. And this part here is the L&B housing. Those arms slide into the slots and you simply screw some bolts in there. These you want to tighten all the way up. Okay, now back to the feed arm bolts, and we just want to secure those. And the feed arm assembly is done. Next, the L&B assembly. It's important to know the polarity of the signal. As you can see by the illustration, the different numbers of degrees refer back to the wave support guide and the pin. Okay, taking those things into consideration, we want to screw together the L&B itself and the housing. This bracket is for mounting the feed horn cover. Note the arrow and the tab. Those need to line up with the top of the L&B to ensure proper polarity indications. Okay, here you just want to get these screws pretty much started, and if you remember that right-angled screwdriver, there it is. That just allows you to get in there and really snug those up. Okay, this is how the L&B mounts onto the assembly. Notice the antenna with an arrow. You want to make sure that that portion of this bracket faces into the reflector. Now these bolts here are 10mm bolts. You can use a socket, or you can use a slotted screwdriver because they do have a slot on them. Make sure you leave this loose so you can adjust your signal polarity when aligning the dish. All that's left to do is to place the entire assembly on top of the mast. Note the inside of the mounting bracket has an adhesion paper shown here. This aids in locking down the dish to ensure proper satellite signal once we have aligned it. Okay, now the grounding block. Note that there's a hole provided. This hole needs to be tapped. We used the screw provided as a self-tapping screw and went ahead and tapped that hole before installing the grounding block. And once you have your grounding block secured, and here is our completely assembled satellite dish. DBS alignment procedures. First, we have a few initial setup items. Number one, you remember when we loosen these mast bolts to place the dish assembly on top of the mast. However, it's rocking and it's not level. So we need to tighten those to where we can still move the dish, however, maintains a good level while we're trying to achieve a satellite signal. These are all 13mm size. Next, we want to do our initial elevation setup. In this geographic location, it requires 45 degrees, so we're going to rough that in. To do so, we loosen all 4 bolts, just slightly. These are the locking bolts, and next we will take our meter indication from 30 down to 45 by adjusting the elevation screw. And we're getting rather close here, and that's about it right there. Okay, and as you can see, we are at 45 degrees. Next, we want to adjust the azimuth. To do so, you move the dish left to right, watching for meter signal or listening for it depending on what type of receiver you're installing. Once you've got the strongest signal, you want to tighten the mast bolts. Again, to do so, use your 13mm socket and go ahead and just tighten those up. One thing to note, however, is that you do want to hold the dish steady because tightening the bolts will move it slightly. And we're about done with that. Now, as you can see, the dish is very stable after those bolts have been tightened. Next portion is to peak the elevation. To do so, you want to raise and lower the height or the look angle of the dish until you achieve the best possible signal. Once you've done so, you want to go ahead and secure all 4 of the elevation bolts. Again, these are 13 millimeter sockets also. And don't forget the other side. There we go. Next, we will peak the LNB. Now, if you remember earlier, we left those screws loose so we could turn the LNB. When you have a signal on your satellite receiver, you want to turn the LNB in one direction until you lose it. I like to mark the indication with a pen. And then you want to turn it in the opposite direction until you lose satellite signal again, then marking that with a pen. Notice the tick marks or indication marks on the LNB assembly. You just want to split the difference there and lock down both of these bolts. They're 10 millimeters. And you're done. Well, here we are on top of the roof, and this is the displacement portion of our DBS installation. What we need to do here is ascertain if we can install a non-penetrating roof mount type satellite dish at the prospective location. First thing that we need to ascertain is if we can actually get or receive a signal from the satellite up in the sky. And to do so, we need to first know where we're going to be pointing our satellite dish. Now, in this instance, we're looking at 209 degrees, and relatively our elevation is somewhere around 45 to 49 degrees. As you can see behind me, and sometimes this will be the case, there's a couple satellite dishes pointing south. If you run into a situation where you're up on a roof, and in general it's a good idea to do this anyway, you need to utilize a compass and just go ahead and take a look where south is. To do so, you just simply open this up. We're going to go ahead and take a look now. You always want to make sure that your compass is level and isn't near any large metal objects that will interfere with the magnet inside. And as I can see here, right there is 209 degrees. So as we pan over, next we need to determine if we have any obstructions in front of us. We need to have a nice, clear look angle, no trees or wind walls or facial walls or anything obstructing our view to the southern sky. And as you can see, as we pan around here, that we don't have any obstructions anywhere even near where we're going to place this dish. Now, if you were to run into a situation where you had trees in front of you, relatively close, a wind wall, maybe a facial wall, whatever, on a roof, a handy thing to do is to take your arm, place it at about a 45-degree angle, look down your arm to the tips of your fingers. It's about a 45-degree angle here, and if you don't see anything, nothing's going to be obstructing your view to the southern sky. Next, we need to determine what's underneath the gravel on this roof. Now, we went ahead and cleared out a portion of the gravel, and as you can see here, we have a rubber membrane roof, which is perfect. We can just place our roof pad on top of that cleared out spot and go ahead and place the dish sled on top of that. So we've determined that we can place a dish on top of this roof. We've determined that we do have a good look angle and we'll be able to receive a signal. And the next thing is cable run. And there's a couple options running your cable. You can, drip it over the side of the roof and drill through the wall and, run the cable through there and seal it as a last resort. But typically we want to try to find a vent or a weatherhead is perfect. That's the optimal condition, or a pitch pocket. Now, looking here on this roof, you can probably see multiple vents, some of them stainless steel with hoods on top. Those are heat vents, and we can't run our cable down those. Other ones that look like mushrooms, they actually have fan motors inside of them. It's not a good idea to run our cable down those because it'll just chop it up. And lastly, you see these white PVC vents in the roof. You can't run cable down those either because it's a gas escape for the sewage system, and we can't break that, or otherwise you'd have sewer gas running through the customer space. So we did, however, find a pitch pocket located next to the HVAC units, and that is where we will be entering the building with our DBS cable. So we've ascertained that we can place a dish and that we have a way to get our cable into the roof. The next thing that we need to determine is where can we ground the cable. Now, the best ground is a structure ground. However, we do not have that available here. So we will be utilizing the ground on the conduit, which per the National Electric Code has to be grounded to earth. And we'll show you that later during the dish installation portion, but it is something that you need to ascertain while you're doing your site survey. The first step in this next process is to place the non-penetrating roof pad. You want to make sure that the area underneath the roof pad is clean. The weight of the sled, which we are placing next, once all the ballast is installed, is anywhere between 240 to 320 pounds depending on what type of block you do place upon it. Also, you want to make sure that this sled is square on the pad. A very small puncture could cost hundreds of dollars to repair these expensive rubber roofs. Next, we want to place a couple cap blocks onto the sled. This is just going to prevent any accidental movement during the dish alignment portion of the installation. Now, the antenna assembly is placed on top of the sled. Remember here not to damage the friction pad inside the antenna mounting bracket. Next, we want to locate the rough azimuth, and we want to align the dish accordingly. We're going to utilize a compass here, and as you can see, Ron is locating 209 degrees, and that is specific to this geographic region and will vary as mentioned earlier. Now he's going to place his compass on top of the reflector and adjust the dish accordingly. This is a very important step in the installation process, and not properly adjusting the rough azimuth or knowing your proper azimuth could add a lot of time to your installation. Now that we have the dish aligned to the rough azimuth, we want to tighten the mast bolts. Getting power to the receiver on top of roof can be a challenge. If you're fortunate, you'll find 110 volts AC at the rooftop HVAC unit. Typically newer buildings or replacement HVAC systems on older buildings will have convenience outlets installed. If you can't get power on the roof, you must have a very long extension cord to get power from inside the building, or you must utilize a DC to AC inverter and take advantage of your vehicle's 12-volt DC receptacle. Lastly, a portable battery pack and inverter is a very viable option. Now we want to connect our test coaxial jumper to the L&B and then to the receiver. Place the satellite receiver in a position where the LCD screen is viewable while adjusting the elevation and azimuth. Now you want to press the preset button followed by 180 on the remote to enable the satellite receiver signal strength meter. Next we want to adjust the azimuth until you see meter deflection and then peak the signal. Adjust the fine-tune elevation bolt and then secure all the elevation and mast nuts. Next, move the test receiver and place the remaining ballast on the sled. Okay, now that all the ballast has been placed, the next step is to peak the polarity of the L&B. Now we're going to penetrate the sealant of the pitch pocket with a drill, and we're going to be careful not to damage the EMT or the gas line. Now we will go ahead and shove some slack down through the pitch pocket of the coaxial cable to enable us to pull the cable to the head end. Okay, so we are here underneath our pitch pocket, and if you remember correctly, that's where we penetrated the roof to drop our cable down. Now, as you can see, it's coming out of the ceiling, and what we did was we went ahead and ran that cable down the hall here, and that open structure, open doorway to the right is where our head end location is going to be. So we have enough cable to go ahead, reach the head end, and have some extra cable. Now, I wanted to point out a couple things before we start running this cable. Coaxial cable is different than speaker cable. It's very susceptible to bends, and if you do have to make a turn up above the ceiling as we're running the cable, you want to have a minimum of a 4-inch bend in the cable if you're going to make a turn. Any more than that and you're going to crimp it, and it's going to degrade the signal quality. You're going to have loss and leakage. Another thing too, make sure that when you pull your feed to your head end that you have more than enough cable. Cable's cheap, labor's expensive, it takes time to make jumpers. Also, you want to minimize the amount of connectors that you have in between the satellite and the head end, because once again you're going to have leakage and signal loss and attenuation. Okay, so as you can see here, we're in the next phase of our cable pull. We've got our loop here. You want to make sure that you have the cable nice and looped out on the floor. That way, so when you pull it, you don't have any kinks. And you want to do this real gently. You want to make sure that you're above any obstructions, any water pipes, you know, other cables, fire alarm cables, etc. So what we're going to do now is just go ahead, pull this cable through. You can see the process. Okay, now we've got all of our slack pulled, and what we need to do is secure the cable above the structure in between the point from this tile to this tile before we move on and replace the ceiling tile. Unfortunately, we're not going to be able to show you that because we don't have any lighting above the ceiling. However, you just want to make sure that you are tied off to some type of structure. You're not tied to electrical conduits, to fire alarm cable, to telephone cable. You want to have this run by itself and just per the National Electric Code.
In this next section, we're going to be performing the cabling and L&B field termination. Here, Ron is fishing the wire through the feed arm assembly. Next, we're going to strip our connection and push on the one-piece F connector and crimp using the RG6 slot. Okay, he has a good mechanical connection. Now he is going to screw that on to the end of the L&B. And lastly, he's going to dress the cable for slack. As we mentioned earlier, we're utilizing the EMT for a grounding point. First, we want to scrape the EMT. This is just to ensure proper connectivity. We're using a two-piece grounding clamp, especially designed for this application. So there's the complete clamp installation. As you can see here, we've just completed installing the grounding wire. Make sure to check your local codes to confirm this method of grounding. Local codes do supersede the NEC. Now that we are finished with our pitch pocket, we must apply some caulk to our penetration. Now we're going to ground the L&B and sled. First step is to secure a ground cable to the L&B. Here's a close-up of the ground screw on the L&B. Just want to insert the ground cable and tighten. Next we'll dress the ground cable down the feed arm and use tie straps to secure it. Now we're going to strip both cables, the one from the L&B that will connect to the sled and from the EMT, which we just showed earlier. Once both cables are cut to length and stripped, they should be connected to the grounding block shown here. Tighten the connection. This is going to ensure a proper path to ground. After this, we'll want to dress the cables by securing them with tie straps. This just ensures that nobody's going to pull the cables out. Please install the feed horn cover. It's there for a purpose, and that is to shield the L&B electronics and your connection from the elements. Now let's take a look at a completed, approved dish installation. We have the feed horn cover installed. We have the dish grounded to an earth ground. Plenty of ballast. Drain relief connections. And this dish should operate error-free for quite some time and well past the warranty period.
We've completed our wire run into the head end location. As you can see, we've run the cable down the wall here, cut a hole in the wall, and installed a trim ring. These are only good for low voltage use. They're plastic with little arms that when you screw them in, they grab the drywall and allow us to attach the faceplate. Now this faceplate is simply a single gang coaxial plate which we removed the female connector out of. Again, we spoke about this earlier, the more connections in the system, the more loss of signal, and on a rainy day or a snowy day, you're just going to lose your signal earlier than you would if you didn't have that installed. So what we're going to do next is go ahead and we're going to install our wall plate here with the screws provided, button up the ceiling,
and put on our F connector. As a sidebar, let's talk about coaxial terminations. Let's go ahead and start off with a single piece indoor type RG6 F connector. The first thing you want to do is strip the cable. Now this is a 2-cut type stripper. It has 2 blades in it, and it's used for all push-on crimp type single piece F connectors. You want to make sure that you don't have any fraying conductors. You want to make sure that you cut all of them and you have a nice clean cable ready to accept the connector. Next, we want to slide on the connector. To do so, you just simply push it on and twist. Note here that you want to check the dielectric. Ensure that it's flush with the body of the connector. And as you can tell, we don't have any gaps, or it's not past the housing. Next, you want to use your ratcheting crimper. Put that in the RG6 slot and crimp. And you can tell we have a mechanically sound, good-looking connection. The next one is a siliconized type, and this is the type that we installed on the roof earlier. You can probably see the silicone in there. Once you put the connector onto the stripped cable, and again, the procedure is to push it on until the dielectric is flush, just like the other type of connector. The only difference here is the silicone will squeeze out when we use our crimper. And again, we use the RG6 die, crimp it, and voila. Lastly, we have the snap and seal connection. This connector fits on just like a single piece F-type. However, the tool is different. You snap it into the special tool, and by ratcheting the handle, you compress the fitting around the coax. Now, this is by far a superior connection. It's impervious to water. It's mechanically and electrically sound.
Okay, and as you can see, we installed our wall plate. We have our cable terminated, and all that's left to do is install the F connector on the back of the receiver here. Okay, we've already come out of the mono audio jack out of the back and connected up to the customer's existing amplifier. The next step is, while you have this turned around, go ahead and make note of the serial number right here, because when we call in to get this authorized, we're going to need to know that. Go ahead and turn this around, and you can see here, change sides, see here that we have our stereo light lit, our sync, our authorization, and our L&B power. All of these are indications that we do have signal to this receiver. And what we want to do next is use our remote. Again, the procedure is preset 180, and we have a signal level of -23. If you recall, on the roof we had a -13. The cable and the connectors did attenuate the signal some. However, this is a perfectly acceptable signal level when you're aligning the dish on the roof. So this customer stands to have a long-term, uninterruptible music service, with the exception of solar outages, which just can't be helped. And we cover those in the theory portion, if you remember. Let's go ahead and make our call to CCS, and just for your reference, that number is 877-305-8324. We're just going to call up,
have them authorize this receiver for the channels that it's supposed to receive, have the customer sign off on the installation, train them, and we are complete.